let's talk about symmetry of functions. And while talking about symmetry of function, we would be interested in talking about even and odd function. So f of x is a function and it is said to be an even function, is even f of negative of x equals to f of x itself, and it will be said to be odd if f of negative of x would be negative f of x. Okay. So that's the definition of even and odd function. For power functions, to figure out which function is even and odd, it's very easy. Let's suppose f of x equals to x square, and suppose another example, f of x equals to x cube. Then clearly this function is an even function. It has power even and its power is odd, so this is odd function. But by the definition, we will try to realize whether they are even and odd function or not. For this one, f of negative of x would be negative x whole square, which is simply x square. That's f of x. So that's even. And for this one, f of negative of x, negative x whole cube. So that's simply negative x cube, which is negative f of x. So f of negative of x would be negative f of x. This power function is odd and this power function is even. Now we know that y equals to x square is even. Then we also know its graph. Its graph is parabola which opens upward. And you can see that this is symmetrical about the y-axis. So we can say this is reflexional symmetry. So even functions are symmetrical y-axis. Similarly, if we take an odd function, let's take the one that we have already figured out, so which is y equals to x cube. This is an odd function, and you can see that when we rotate this entire curve centered at 0, 0, that's the origin, in 180 degree, then this curve is symmetrical about the origin. Okay, so we say that this is symmetrical about the origin. Symmetrical about the origin 0, 0. Other names for even this symmetrical about y-axis is, this is a reflexional symmetry, and this one is rotational symmetry. Centered at 0, 0, rotating about 180 degree.